Very good morning, dear students. So today's session is continuation from the previous session, region-based segmentations. In the last class, what we discussed adaptive thresholding. So what you mean by adaptive thresholding? In adaptive thresholding, you have to set. You can run automatically set the threshold. Suppose the threshold range we have to fix from 0.2 to 0.3. In between adaptive thresholding, how to adjust 2.1, 2.2 or 2.3 like that. Means that is based on their requirement. They are going to adjust it. That is what we called as adaptive thresholding. In adaptive thresholding, many applications they are going to use adaptive thresholding only. So adaptive threshold it helps to the in real-time applications to adjust the automatically. Now I'll come to that the next concept, region-based segmentations. So what you mean by region-based segmentations? In region-based segmentations, the edges and thresholds sometimes do not give good results. For the segmentation, by the time we can go for region-based segmentations. In region-based segmentations, the object boundaries was traced to locate an object. The object region is used to locate the object. To finding an object by locating either its boundary or region should result in the same object as a boundary, and regions are just different representations of the same object. Similarly, in the edge-based segmentation approach may give totally different results than a region-based approach. Imperfect images, imperfect methods can be reasons that the practical result of object detection using boundary-based approach in different from region-based approach. The region-based method rely on the assumptions that neighboring pixels. One common approach is to be compare a pixel with its neighboring pixels. Suppose an example, a pixel belongs to some clustered as 1 if its neighbor of it satisfies some similar criterions. By the time we can use for region-based segmentations method, and these region-based segmentations we have two basic operations. One it is called as a merging, second one is called as a splitting. What for this merging and splitting? In the merging and splitting, we go for both region-based segmentation and edge-based segmentation. For example, you can take region-based segmentations. Each region should be uniform. And the connectivity of the pixels, it may be within that region. That is very important. In the region-based segmentations, what we are going it merging and splitting. The merging will be called as a region growing. and splitting will be called as the region splitting. Some basic boundaries we are using. Before that, I'm going to conclude some of the growing based segmentations. That is what initial segmentation of the image. Merge two adjacent segments to form a single segment. We can take separate two adjacent segment to form a single segment. The initial segmentation can be all individual pixels. The basic idea is to combine two pixels if they are similar, can be used on gray level texture of the segment. Similarly, we can go for splitting. First, we can take the initial segmentation of an image, split each segment that is inhomogeneous and the initial segmentation may be entire image for inhomogeneity of a segment may be variance of the gray levels or the different textures. Some examples we are going to discuss in the future slides. Here we can take some mathematical morphological functions we used in these slides. Yeah, now you look into that. Region based segmentations. The region is growing. The region growing is a process of merging adjacent pixels segment into the one segment, and it is one of the simplest and very popular method of segmentations which is used in many applications. It needs a set of starting pixel that it is called as a seed points. The process consists of picking a seed from the set of elimination or eliminating 4 to 6 N4 or N8 neighbors of the seed. The algorithm may be continuous until the seeds set to the empty. So for that directions we have 4 diagrams. The first one is image showing defective weights. The B, second one. The result of region growing. And the third one, we look into the third one. Boundaries of the segmented defective weights in the black colors. See, look into the very clear. And the last one is D, boundaries of the segmented defective weights. See that comparison from one image to the next image. So in these region growing, we can use the image segmentations here. See, please look into that image segmentations. And region splitting is a opposite of region growing. First, there is a large regions possible, the entire images. Then a predict is used to determine if the region is uniform. If not, then the method requires that the region be split into the two regions. Then each of these two regions is independently tested by the measurement. This procedure continues until all resulting regions are uniform. See here, very clearly it indicates that splitting, the main problem with the region splitting is determining where to split your regions. One method to divide a region is to use the structures. The tree in which nodes have exactly 4 descendants. See, look into this. The split and merge procedures. Split into 4 disjoint quadrants. Any regions Ri for which then you go for segmentation by morphological watersheds. The concept of watershed is based on the visualizing the image in 3 dimensions. This is only the point of your understanding, but it is the syllabus is not mentioned the morphological concepts, but for the concept wise, see here, these are the different examples. Original image, topographic use, two-stage flooding. See here, there's continuation for this. Okay, these are the examples what we studied in the image segmentations. Okay, thank you. I will continue in the next class in the next concepts. Thank you very much.